Okay, so I'm going to talk a little bit about some static probes that we added to DTrace and how we used those for getting some information out of some of specifically the vlserver, but the concept is kind of general. It says DTrace SystemTap up there. All the stuff that I've done is DTrace, but I know a lot of people don't care as much about DTrace or care about Solaris. So the plans for this are to I was planning to do some of the some similar things with SystemTap as well, but everything you're going to see here is Solaris specific or is DTrace specific. I ran it on Solaris. Maybe it runs on there are some DTrace ports for other platforms, but I don't know as much about those. So we already heard a lot about SystemTap. Yadav went into a lot more detail than I'm going into here, and he already explained things very well. DTrace is very similar. In this talk, I'm going to be talking about user space, the user space applications of DTrace. So in general, okay, so there are certain events that happen, and we just specify certain things that get triggered when those probes are triggered. So in this case, we're primarily concerned about function calls. So when a certain function is called, you record some information, print out some stuff, do something. And typically you don't need any, I guess I can't get that to go away. You don't need any special support in the binaries that we're compiling. Everything gets the basic per function traces, they get them automatically. And DTrace in particular is known for having some very convenient, very concise ways of doing things that are sort of kind of complicated under the covers. So you have these, if you want to record what the sum is for all the times a function is called across many different threads, normally you do something with locking, or you have to record values per CPU and aggregate them later, something like that. A lot of that stuff is done it's a primitive of the language that DTrace scripts are written in, so it's very quick, very common to do. So that it just makes things a lot easier. And when getting all this information, of course, we don't need to set up any logging, any auditing. There's no separate daemons. There's not a lot of setup you need to do. So that's why a lot of people like to use this to very quickly get some information out when stuff is running, both in DTrace and SystemTap and anything else, any other similar system. There's other ones that exist too. So this is just a very simple generic example just to show what it looks like. We just saw much more useful examples in the SystemTap world. So this is just anytime a function called some function is called, then we would print out that it was called and see what the first argument was. Assuming the first argument is an integer, we're just assuming that because we happen to know. And just to illustrate, I feel like some people that are not used to using DTrace or similar systems, you see this script and you don't really know what to do with it. I just wanted to demonstrate that file is really all you need, and you just run it like that. Like you don't feed it into anything else. That's all you got to do. A similar, very simple generic example is to, instead of printing out something, we record the sum. So even if it's in different threads, we still get a consistent sum that we get there. And the way that works in particular is once you stop the script from running, it would print out, DTrace would print out the total for you. So now moving on to some examples you actually might want to use with OpenAFS. If you want to see when people are querying the vlserver, or see what volumes are being looked up in a particular vlserver, you could use a very simple script like this. So we just know that the function that is called in that code path is called svl getEntryById. There's a few variants of that function, so it's a glob that catches everything that's named beginning with that. And so anytime that's called, we know somebody has looked up a volume, and we know the volume ID is in arg1. So that's a very simple way to get very simple data. But as soon as you want to do pretty much anything, or sorry, there's another example just by name. So if you look it up by name, you print out the name that somebody looked up. But as soon as you do anything like one step further, you want to get a little more information, then we have to start digging into the actual structures. And with DTrace on Oracle Solaris before a certain point, that means you have to know what the hard code, you have to hard code what the offsets are into structures and copy the memory back out. So this is like all we want to do here is we want to get the volume name that was looked up and what IP address was making that request. So that's not a very complicated thing. It's a very reasonable thing to want to do. But to do that, we got to go through 4 structures. We have to know what the offsets are, and we have to know what the types are and all that, and copy things back out. So obviously that it's very low level. It's awful. It's very not maintainable. It's very annoying to do that. So in addition to, so we have to know the function names first of all. So you have to have some developer knowledge. Function names can change. They do change all the time. Those ones in particular do not really, because they're tied into the protocol. But a lot of other ones, you know, stuff moves around all the time. It's not a public interface, so they will change between releases. And the same thing with the structures. Since we're manually unpacking structures there, we hard code all the offsets. So those definitely will change over time and can change between builds in the same release. So that's pretty awful. So some things, so SystemTap does a lot of stuff with, if you have the debugging symbols in there, it can automatically do the types for you. So you don't have to do all these hard-coded offsets. DTrace also does that, I believe, in like the open version, like the version that's in Lumos and stuff like that. The Oracle one, I think, is supposed to get it. I don't know what the schedule is for that. But the thing is, even when you have that, you still need to have all this other developer level knowledge. So you still need to know the functions, and you need to know what structures you're looking at and where, like if you want to know what the host is, what the IP address is, you have to know that it's in a, you know, you get a call, you have to go into the connection, and then the peer, and then the host is inside that. So a lot of this is very, it's like a developer tool. It's a lot of developer knowledge that's required. And a lot of DTrace scripts and a lot of what DTrace is useful for is for systems administrators that don't necessarily need to know all this low-level information. So it would be very helpful if we had a higher level interface that was unchanging between releases, so you could run scripts and develop scripts and they would work across different releases. So we did that specifically for vlserver requests. So here's an example script that would use those probes. The probe, I just picked the names called get entry start and get entry done. Start is when the request has begun and done is when it is finished. So in the done probe, we get some more information like the error code and some more information of the VL entry, assuming it was successful. So if we have a successful one, not only do we have the volume name, but you can get the volume IDs, the various servers that it's hosted on, and vice partitions, all that information. So here, you see these are, there's no hard-coded offsets. These are like logical, high-level things that are easier to, a little more intuitive to understand. And so we do this, the way we implement those is what DTrace and other things call SDT probes for statically defined tracing, as opposed to the dynamic probes, which are all the ones you get automatically. So normally you get one probe per function. This is a probe that we define separately, so several functions may call it, and several functions do. And as we move things around, refactor things, change function names, this stays the same. And that really covers just like what the probe is called. To get the data out, so we don't need to be reaching into structures and looking at offsets and things like that. There's another file that we can ship, and if you put it in that path, DTrace will pick it up automatically. That does some translation from the data that we provide to DTrace, that the OpenAFS, that the process provides to DTrace, and we translate that into like a logical thing that the script can understand. So this is just an example of a piece of what one of them looks like. This is translating a struct called args called infoint for like internal. It's our internal structure that we pass between the process and the DTrace like kernel space stuff. And it translates it into something called a coninfo_t, which is a common, it's like the official structure for representing endpoints, like an IP address and that kind of thing. So that does, it copies in something from a certain offset, but we know what it is because we have the, there's like a header that we export that has this information in it. And so this is just saying we copy in that value from that structure, and if it's 0, then we translate it into the string unknown, which is just the common, that's what DTrace stuff tends to do. If there's no host, you just call it unknown. And if it does have one, if it's not 0, then we run it through inet and TOA, so that translates it into a string, the dotted quads. So as an example of what you can do with these kind of scripts is you can develop something like this. This is an example script I call vltop, which is just to show on a running vlserver what are the volumes that are being accessed. Like as they're being accessed, you see the most frequent ones on top, and you can get some statistics out of it. So in this, I print out how many requests per second, how many requests that return an error per second, and what percentage belong to which volumes. And some of these are percentages, and the W time is the wall clock time, the V time is the CPU time, and that the column that actually says percent CPU is the percent CPU of like the entire machine, I believe. So this is just me running some, VOS list VL commands in a loop just to get some stuff to appear. I don't know how, I don't know how useful this actually is. This is just kind of an example, the kind of thing that you can kind of see. I'd probably more want to see something like this for RX. That would probably be more like a more useful tool to see what RX calls are like causing the most traffic or causing the most CPU usage, and then you can see what RPCs they're running, so you can see what specific calls are doing various things. But this, the general information provided here from the vlserver, I assume is useful because the client was asking for it. That's why we did this. But that particular script, that's just me fiddling around with it. So in the future, I would like to add, I'd like to add it to more subsystems. I think that would be a bit useful. Things like RX, you could have logical events, things like if you resend a packet, you could fire a trigger for that without having to know what the function is. And receiving packets and things like that, when calls are created and destroyed, events of that nature. So I said I wanted to include SystemTap in here because I know people probably care about that more. The code changes in OpenAFS to do this stuff is actually can be identical between DTrace and SystemTap. So we don't need to change those macros at all if we don't want to. There are SystemTap ones, but they have compatibility macros for the DTrace ones. The build system is another question, is something else. I imagine that requires more work. At least I hope it does, because the Solaris build system for this is really weird. I don't like it, so I hope it's different for SystemTap on Linux. So I haven't looked into that too much yet, but I assume that I wanted to have the probes be called like the same thing across different implementations, so you don't have to have the DTrace ones and the SystemTap ones are called something else. And I assume that if we did it in SystemTap, it would look something kind of like this. Since I haven't actually done it, I don't know. This is just based on general knowledge of looking up SystemTap related things. So the same probe that we saw before, get entry start, would probably look similar to this. But I'm not too sure. Okay, so like before, the code is there, top commit is there, that'll get you everything, and all the individual commits are in Garrett under that topic, and the slides are there. Okay. Any questions? Yes. Yeah. I don't know. You mean on Solaris, or is that a Linux thing?
That's what I was asking. Is something equivalent to uproot on Solaris?
I don't know. Well, yeah, I'm not familiar enough with the Linux implementation of this stuff to know. The question Yadav was asking is if DTrace uses uprobe or something similar to uprobe on Solaris for implementing it. The way that it works, I think, on Solaris is that it inserts no-op instructions and then replaces them with things that trigger an interrupt into the kernel, and the kernel does all the processing to detect where the where that address is and see things. So that was similar to what you were saying. I thought you said in Linux it like overwrote some instructions, so there weren't even no-ops when it's turned off. Yeah, so it's similar to that, but this uses no-ops in place. I'm not really sure if there's a reason for that or just how that's always how it's been done. And that might be wrong. I haven't really looked into the details of that, of how that works, but it's a similar thing where if it's turned off, when we turn it on, we replace the instructions and it gets replaced with a trap. And so all the processing goes through the kernel. That is relevant for writing some of the probes because you're not, the probes, when they get translated, they are running in like kernel space. So you need to copy things from user space into kernel space in order to process some things. That's why printing out strings is not simply just printing the pointer to the string. You have to copy the string into place in order to print it out.
And in the presentation, you showed that OpenAFS.d was placed in some DTrace location.
Yeah.
So is it that it contains the multiple DTrace files from different subsystems? Is it the common location?
Yes. So this is, where was it? Yeah, there. So Yadav is asking if this is the location where other subsystems put stuff into for automatic translation in DTrace. And yeah, that's where it is. There's a bunch of other stuff in there. I don't think you have to put it in there. I don't actually remember how to load it if it's not in that path. I think I'm sure there's a search path or something for it, but I don't remember what it is. Yeah, so there's other stuff. And so I'm trying to follow, with these like names and conventions and stuff, I'm also trying to follow kind of the same conventions that exist in other DTrace subsystems. So we actually, the person that was requesting this functionality requested some advanced, like some of this is a little more advanced functionality than a lot of other things do. So something, like even these translators, not a lot of things use the translators in third-party software. A few things do built into Solaris, but even ours is pretty, we do a lot of stuff. So there's not a lot of examples sometimes for what we're doing.
And, most of the time I've seen with the dynamic tracer is that sometimes compiler optimizes the things, right? So
yeah.
Some of the variables might not be available. So
yes.
Do we have something in DTrace to know beforehand what are the things we have available?
Well, so these, yeah, so these, we don't, I'm not sure if you can get local variables from these, actually. That's not something I'm used to doing. Maybe there's a way to do it, but I don't know what it is. Typically, we just get arguments to functions and return values. So
you can get it from the PID provider for user space.
The local variables?
Yes.
What's it called?
As long as the CTF information is present.
Yeah, but it's not arg1, arg2, arg3, because those are function arguments. We're talking about local variables that are not arguments.
Yeah.
So what?
As long as they're in CTF, it'll
You just call them by their name?
Yes.
Okay. I hadn't done that. So I don't know if, do you know if there's a way to list which ones are available ahead of time?
So I think you get the PID provider to list them. I can't remember for sure. I just used it recently, but I don't remember. Okay.
And it's also true that, of course, sometimes functions themselves go away for during optimization. So and listing probes, of course, is a normal thing to do. So I said before, you get it for every function. Technically, that's not true, depending on how you define function. The only dynamic probes you get are the functions that actually exist as functions in the resulting binary. There's also, you can get some confusing behavior too when sometimes we've used DTrace before to try to debug LWP programs, and you'll get cases where like you'll have a function entry probe fire, but the return probe will never fire because LWP like jumps to a different location in the code, so we never actually return from it. So sometimes you get weird behavior like that as well. Okay. Oh.
When I use regular expressions with DTrace, for example, to print something every time that any function that starts with RX is called.
So Marsha is asking if we can use regular expressions for the probes. So we can't, there's no regex, but there's globs. I show that like here, like get entry by name star.
Oh.
So anything, yeah, so you can do RX star, but you can't use actual regular expressions, which I actually wanted to use before because of there was a certain specific subset of things I wanted to probe, but I couldn't, like it was too complex to do with the glob. So if you can't actually do it with the glob, then you have to list all the probes that you want to list, which is really annoying.
Well, they have to be careful with, like for this case, they did a by name variance. We still assume that the first argument, arg0, is going to be of the same type, so that hard-coded offset is going to have meaning.
Yeah.
That's-
And I mean, that is true of these.
Yeah.
Yeah. So normally you'd only use for something like this, you'd only use the globs for functions like that, which only, they only differ in the type of the last argument or something like that.
Yeah.
All right. Well, thank you.